As a young citizen of India, armed with technology, knowledge, and love for my nation, with a vision of transforming India into a developed nation, I'm joining Shobhit University. What about you?
Very good morning to all the participants from India and abroad to this international webinar series today. Soviet Institute of Engineering and Technology Meerut, deemed to be university, and its a Center of Excellence, Center for Informatics Development Solutions and Application, and Center for Industry 4.0 Studies and Application, in association with African Asian Rural Development Organization, ARDO, New Delhi, organized this weekly international webinar series on open source digital technologies towards self-reliant India, Atmanirbhar Bharat. Today is 26th June 2021. On behalf of the Honorable Chancellor, His Excellency the Secretary General ARDO, Honorable Vice Chancellor, the faculty members of the university, and on my behalf, and as Professor Emeritus and Chairman of the Centers of Excellence, Center for Agricultural Informatics and E-Governance Research Studies, Center for Agribusiness and Disaster Management Studies, Center for Informatics Development Solutions and Applications, and Center for Industry 4.0 Technology Studies and Application. Welcome our guest speaker of today's webinar, Mr. Vishnu Chandra, Deputy Director General and Head of Group, Geospatial Technologies and Services Division, National Informatics Center, Ministry of Electronics and Information Technology, Government of India, New Delhi. The topic is National Digital Twin Program, Need for a Robust Geospatial Infrastructure. Mr. Vishnu Chandra, for your information, under this international webinar series, these two centers of excellence, that is Center for Informatics Development Solutions and Application and Center for Industry 4.0 Technology Studies and Applications, have organized 33 lectures so far in the areas of open technologies to provision simple and economical IT infrastructure, a roadmap for students using free and open source software and reaching goals of Atmanirbhar Bharat, open source software and industrial IoTs for SMEs, free and open source software adoption, public business models, open data platform for smart digital government, technology imperatives, make in India for self-reliance, edge artificial intelligence, data governance for self-reliant India, digital India transforming governance and society, India email service citizen@indiamail.com in 22 constitutionally recognized languages, ecosystem architecture for digital transformation, education systems, cyber critical infrastructure, seizing opportunities in open innovation and value creation network in the digital world of self-reliant economy, ensuring food safety and compliance through technology, digital India, urgent need for semiconductor manufacturing in India, technology investment in agriculture value chain, role of foreign direct investments, entrepreneurship and skill development, AI design pathways, the rise of platform economy, revisiting value chain governance, the era of automation, industrial robotics, and Industry 4.0, Indo-German perspective of technology transfer, skill gap, analysis, and opportunities, role of artificial intelligence in healthcare, current developments in diagnosis and vaccine research, digital agri-tech and agri-startup perspective, health informatics network value chain, e-health systems, and beyond. Leveraging emerging technologies for ensuring transparent and traceable agricultural and food supply chain. Unleash the power of citizen development for enterprises after development. E-governance models towards sustained quality services to citizens backed up by technology. Indian MSMEs to adopt Industry 4.0 technology capabilities. Urgent need for mentorship and accelerator program. Building public digital platform using microservices and APIs. Health informatics network value chain. Early childhood development and learning. Health informatics network value chain, clinical artificial intelligence, interface between machine learning and health informatics. Health informatics network value chain, importance of social medicine and community health in the times of health emergency. Gravity filter, G-filter, a simple low-cost solution to the drinking water treatment in rural India. Open source GovTech startups, empowering growth and automation, giving an example of building plan approval. Digital transformation in small enterprises and small businesses of India, challenges and opportunities. Today is the 34th edition of this very important webinar series. This talk will be given by our guest speaker, Mr. Vishnu Chandra, Deputy Director General, National Informatics Center, on a very important topic, National Digital Twin Program, need for a robust geospatial infrastructure. Dear participants, please note down the keywords. National Digital Twin Program. Need for a robust geospatial infrastructure. All the experts and students of geography discipline, please look into this very important title of the talk. National Digital Twin Programs. We have more than 506 smart city projects in the country. Do we have a robust geospatial infrastructure? Today, our guest speaker will address this issue. To recall, on 12th September, Dr. B. Balasubramanian, Deputy Director General, former Director, Deputy Director NIC, talked on open technologies to provision simple and economical IT infrastructure. On 24th October 2020, Dr. Petruraj Chellaya, Chief Architect and Vice President from Reliance Jio, talked on Edge Artificial Intelligence. On 21st November 2020, our former Secretary to Government of India, Mr. J. Satyanarayana, IAS retired, talked on an ecosystem architecture for digital transformation. On 5th December 2020, Dr. Jebamale Vinanchi Arachi, former Principal Advisor to the Director General, United Nations Industrial Development Organization, Vienna, Australia, talked on the topic Seizing Opportunities in Open Innovation and Value Creation Network in the Digital World for Self-Reliant Economy. On 12th June 2021, Mr. Prakash Ramaswamy, Strategic Advisor, Autometry Technologies, talked on open source GovTech startups, empowering growth with automation. And he talked on a case study which they built up with the open source technology on building plan approval in every urban bodies and panchayat development bodies. Atmanirbhar Bharat is the road ahead. This is the vision of Honorable Prime Minister Shri Narendra Modi for making India self-reliant nation, rested on 5 I's: intent, inclusion, investment, infrastructure, and innovation. Based on 5 pillars: economy, quantum jump, not incremental; infrastructure, one that represents modern India. Today, under the category of infrastructure, we will talk about the need of a robust geospatial infrastructure. Systems, 21st century technology driven for vibrant demography. They are the source of energy for self-reliant India, and demand, whereby the strength of our demand and supply chain should be utilized to full capacity. It is this demand chain and supply chain will play an important role in National Digital Twin Program. Vocal for local, for making it global. Digital world, facilitating the rise of digital economy. The digital economy has the following technology components: blockchain, data analytics, artificial intelligence, 3D printing, Internet of Things. Now, new technologies come, interface of things, automation and robotics, and cloud computing. Platform economy is economic and social activity facilitated by digital platform. Platform economy is emerging, and we need digital ecosystems which are essential for digital transformation in the digital world. Industry 4.0 is today, and Industry 5.0 is tomorrow. And the key technologies are categorized as A, B, C, D, E. A means artificial intelligence, analytics, operation research. B is blockchain. C is cloud, IoT, 5G communications. D, big data, and E, ecosystems. Digital transformation is building public digital platform using microservices and open APIs. Microservices architecture and APIs for the development of public digital platform is emerging in India. You have digital education platform and digital health platform and etc. Digital agriculture platform. In the digital transformation and the digital platform, the data underpins the 6 P's of digital services, which are all the 6 P's: personalized, paperless, presence-less, proactive, perceptive, and pervasive. So every government digital platform has to meet these requirements. They have to, they have to facilitate the 6 P's of the digital services. Let me quote once again: personalized, paperless, presence-less, proactive, perceptive, and pervasive. The university also has plans to launch the following course to generate appropriate human resources personnel in the under the program MTech in Geospatial Technology, Geoinformatics, 2-year, 4-semester postgraduate program, diploma and 6 months diploma in Geospatial Technology and Geoinformatics, and PG diploma in Geospatial Technology and Geoinformatics. Appropriately, the digital twin program will be incorporated. Digital twins. Digital twins are realistic digital representation of physical aspect. It's a virtual representation that serves as the real-time digital counterpart of a physical object or process. According to a report by Global Market Insights, the market value for digital twin market by 2026 is more than 35 billion US dollar. By 2026, digital twin market is valued more than 35 billion US dollar. As of now, that is by 2019, their market value is about more than $4 billion. From $4 billion in 2019 to 2026, it is going to be more than $35 billion, or more than 9 times. And this is an important thing that one has to look into it. We'll have an interaction and collaborations, and digital twin ecosystems, and the data fusion and services. The services says that save energy, reduce pollution, encourage recycling, reduce variability, enhance productivity, prognostic health management, improve workflow, object life cycle, optimize delivery and maintenance. And these are all very important, services level outcomes. And we also have a data fusion, update frequency, twinning rate, cyber physical systems intelligence, human interaction, digital model richness or digital model fidelity, dashboard development. Emerging technologies are 3D printing, advanced materials, advanced analytics, advanced robotics, and cognitive automation, artificial intelligence, biotechnology, biomanufacturing, blockchain, security, digital design, digital simulation, digital integration, energy storage, high performance computing, next generation computing, Internet of Things, Internet interface of things. There is augmented reality, virtual reality, mixed reality, wearables, and gesture, recognition. Now, this has been clubbed under the new terminology called interface of things. No digital twin without digital thread. So it's like it's a national expressway. The 14 lanes become a digital thread. And a digital twin refers to a digital model of a particular asset that includes design specification and engineering models describing its geometry, materials, components, and behavior. Digital thread refers to the communication framework that allows connected data flow and integrated view of the asset's data throughout its life cycle across traditionally siloed functional perspective. Traditionally siloed for functional perspective. It means silo portals created by individual departments, both public sector and private sector, government sector, cooperative sector, and so on and so forth. Digital twins in India is still infants at the inventory level, but with great promise. We moved from 2D, that is CAD, computer aided design, 2.5D, JS, 3D, building information modeling, and 4D, fourth dimension, is digital twins. The 4D digital twins at the critical dimensions of time to provide evergreen visibility, according to Bentley Systems. Digital twins are still infants, but with a greater promise, according to the report in DataQuest May 2021, as recent as it is. It has a potential to drive unparalleled efficiencies in Industry 4.0. You have an Industry 4.0 technology, people talk about it, but you have to have a digital twin which has the potential to drive unparalleled efficiency in Industry 4.0. Manufacturers will prefer to use digital twins to improve operations such as plant processes and to optimize supply chain. Digital twins reduce risk because the mistakes can be made and corrected offline instead of during an actual production or in a working facility. Let me quote, in India, the state of Andhra Pradesh announced in 2018 that it would build a new capital in Amravati based on CITSA platform. A change in government and loss of funding stopped the project, which would have used the digital twin platform to plan, design, and build the new greenfield city. Smart cities look for digital twins. According to a report on March 1st, 2021, this report says that by 2025, some 500 cities around the world will be using some sort of an urban twin, up from a handful now. They are being used to replicate buildings and their systems and operations, infrastructure such as highways, surface transport systems, and pretty much everything that comprises an urban neighborhood, town, and city. It will create a Midas effect across industries, be it in optimizing automotive value chain, or aircraft innovations, or digital oil drilling models. Forward-thinking manufacturers are already benefiting from digital twins. For example, manufacturer of passenger vehicles created digital twins of vehicles sold. While vehicles are simulated in factories, data transmitted via sensors from vehicles on the road are interpreted by artificial intelligence to evaluate their functioning. Digital thread will be needed. Will be the needed digital thread will be the needed robust geospatial infrastructure, since a digital twin's success relies on availability of data. Insufficient data can make the models ineffective. I wish to quote National Digital Twin Program of the Center for Digital Built Britain. High quality, secure data can improve how infrastructure is built, managed, operated, and eventually decommissioned. It is therefore crucial that this data is captured and used effectively to bring forward savings for stakeholders and ensure social benefits for all. This focus is reflected in the objective of National Digital Twin Program of Great Britain. Enable a national digital twin, an ecosystem of connected digital twins to foster better outcomes for a built environment. Deliver an information management framework. Align a digital framework task group. The benefits are the benefits to society, benefits to economy, benefits to business, and benefits to the environment. Less disruption and waste, more reuse, and greater reuse efficiency. A key enabler of circular economy in the built environment. Key enabler of the circular economy. Developing smart city requires many types of information, including geospatial information. Geospatial information serves as the base data from which other data will be referenced upon. In recent years, development of spatial data infrastructures played a crucial role in urban development, and it has become the important platform for exchanging and sharing spatial data information to facilitate the availability of resources in the proper planning of smart cities and projects. So, the digital twin needs a robust geospatial infrastructure. The relationship between digital twin and geospatial infrastructure is symbiotic in nature. Geospatial infrastructure is required to model and simulate changes in the real world that fits into the digital twin ecosystems. Subsequently, a connected digital twin ecosystem will open doors to a whole range of geospatial applications in various economic sectors, creating a robust geospatial knowledge infrastructure. Smart city versus geospatial infrastructure, smart city versus digital twin, smart city versus geospatial infrastructure, and versus digital twin. With this background, let us now turn to the address of Mr. Vishnu Chandra, Deputy Director General, on the topic National Digital Twin Program, Need for a Robust Geospatial Infrastructure. As per the synopsis of the guest speaker provided to me, the synopsis says, the spatial data infrastructures as a major component embedded in digital twin systems bring location intelligence of physical space or real world. This is created to streamline people, process technologies, and deliver a wide array of data. Open Geospatial Consortium plays a major role in terms of standards of data interoperability and exchange among various subsystems of SDI vis-a-vis digital twin ecosystems. This topic will motivate and galvanize the participants watching over telecast through facebook.com/Sobit University India or youtube.com/Sobit University in for motivating them to establish Industry 4.0 tech-enabled digital twins startups to harness the powers of transformers, technology, and capital to modernize the operations of small and medium businesses, micro, small, medium enterprises. This will lead to empower India through Make in India 2.0 more vibrant. Let us establish a national digital twin program for Britain as it is being built by the Center for Digital Built Britain, University of Cambridge in India. Let us build a model national digital twin program in India. Let me introduce our guest speaker to the participants of this webinar. Mr. Manish. Mr. Vishnu Chandra is the Deputy Director General and Head of Prof. Geospatial Technologies and Services Division, National Informatics Center, Minister of Electronics and Information Technology, Government of India, New Delhi. He has a strong academic background, science graduation from DBS College, Dehradun, Karwal University, MSc Physics, MPhil Instrumentation, and MTech Electronics and Communication Engineering from University of Roorkee, now IIT Roorkee between 1978 to 1986. After a brief stint in the electronics consumer industry and also as a lecturer at the BITS Pilani, Mr. Vishnu Chandra joined in 1988 the Department of Electronics, Government of India, and was associated with System Engineering and Consultancy Group. He was then involved in projects for National Airport Authority for modernization of airports, specifically for automatic self-briefing systems for pilots and airport FIST services and automatic meteorological systems for airports. In mid-1990, he joined National Informatics Center at the Uttar Pradesh State Unit, Lucknow, and was instrumental for the Natural Resource Informatics Systems, NRIS, to strengthen the district program. Major achievement during stay at the NIC Lucknow was the State Plan of Action for NRIS with case studies from District Aligarh, Bulandshahr, Mathura in collaboration with Remote Sensing Application Center of Aligarh Muslim University and UP State Remote Sensing Application Center. In 1994, he had taken over as the head of Natural Resource Informatics Division at NIC headquarters, Delhi, and this facilitated his journey in the domain of geospatial technology and services. During the last 25 years, he has achieved a lot, and his services and projects have received a lot of laurels and accolades and varies from both the national and international platform. Mr. Vishnu Chandra is currently heading project divisions of NIC associated with the Ministry of Housing and Urban Affairs, Ministry of Power, Ministry of Non-Renewable Energy Sources, Ministry of Coal, and Ministry of Environment, Forest and Climate Change, and also the National Disaster Management Information System Division of NIC. His contributions towards GIS-enabled ICT platform initiatives such as National Power Portal, E30 Geo Portal, Smart City projects for Greater Noida, GIS platform for slum rehabilitation in Mumbai, Parivesh platform for environment, forest, wildlife, and CRZ clearances, ICT and GIS platform for mapping of Abadi land using drone data and Swamita scheme, and so on and so forth. These projects are recognized, published, and awarded at various platforms. National Informatics Center is moving towards creating a cloud-based system of systems platforms embedded with open geospatial consortium compliant geospatial infrastructure and services to be further scaled up to digital twin ecosystem services. Mr. Vishnu Chandra, we are very happy to welcome you to the international webinar series on open source digital technologies for self-reliant India, Atmanirbhar Bharat. On the topic, National Digital Twin Program, need for a robust geospatial infrastructure. Over to you.
Thank you very much. I extend my acknowledgement, and I feel really proud to be associated with this international webinar. I convey my thanks to Professor Moni. In fact, he is my mentor in NIC, and I have learned a lot of things from him. And I just now going to share my presentation. Uh, hope it is my presentation is visible.
It's not
Hello?
yet. Mr. Manish?
No, sir. No, sir.
Is it visible?
No, sir.
So thank you very much. Good morning to everybody. And
No, it's not visible.
No, sir. It is not visible, sir.
it is not visible.
No, sir. So share again, sir.
Is it visible?
No, sir. Sir, share again, sir. Share again.
You
Okay.
come out and share. Okay.
Now, sir, it is visible. Open the PPT now.
Okay, good.
Yeah, now it is visible.
Yes.
Yes, sir.
Yeah. So thank you very much. As Professor Moni has given a lot of good foundation for, and it is really helpful for me. And today the points which we are going to cover during my course of webinar and discuss the topics relates to digital twins, spatial data infrastructure, geospatial framework, what digital twin means, then certain infrastructure and platform, including GIS platform of NIC Bharat Maps, frameworks developed, and how important is systems of systems approach in context of digital twins and spatial data infrastructure, that along with planned policies of geospatial technologies is going to be covered during this presentation. The vision statement, in fact, Professor Moni has already set up a good foundation. As per the topic title of this webinar, a city or urban space which people call their home has two dimensions. One is physical dimension, and physical dimension means geography is core to it. See, physical dimension incorporates geography and infrastructure. So location intelligence is part of physical dimension, which is very important in context of geospatial as well as digital twins. Then another is social dimension, which relates to the human being, people, citizens, and associated culture. So these two dimensions are integrated in a digital twin system. Third dimension, apart from physical and social dimension, which has now well recognized across the globe, is digital dimension. So how you represent physical space as well as social space digitally and integrate on real-time basis to have a interconnected world, that is the key to digital twin ecosystem. Activities such as which capture fabric of a city, like city planning, financial transaction, social exchange, real-time transit and updates. They now in many of the platform services related to governance are happening in digital world. So those things are very important, and the vision is to harmonize and democratize these virtual events and creating interoperating digital platform where decision makers and various stakeholders of maybe a planners, maybe a people dealing with say transport sector, power sector, can monitor, simulate, predict, and plan the current situation and also future state. So they can plan future cities. So as Mr. Moni has said, the digital thread of information, real-time information from physical space will be analyzed using various data models to predict what will be the state of city and what kind of plan we should have down the line 5 years or 10 years or 15 years. So that these platforms has to come to be known as urban digital twins, and they provide critical interface to various organizations and also decision makers at various levels. Now, as we say, digital twins definition is can be classified in 4 compartments, as the slide says. The digital replica of complete physical world, where all associated things, places, and processes with it within its area are machine readable and subject to power of algorithm, making them digitally accessible, infinitely connected, and autonomously intelligent. Now, this is the core requirement, and how it will be done. It will be done today will be with real-time systems which will act as a digital thread through IoT sensors, big data, cloud computing, and uh, combined with what you call a new emerging platforms like interface of the things, 3D models, geospatial data sets, and building information and management systems. Now, the promise of the city to digital twin is to simulate the environment, to select, to identify policy options, to bring out dependencies among various silos, so and interconnect them. So you have to have lot of policy intervention for information exchange, for data exchange, data interoperabilities and standards, and some kind of collaborative and cooperative framework where different stakeholders can talk to each other around what you call common specifications and standards. So this will lead to improvement of engagement with citizens and communities, and definitely this kind of digital transformation will lead to more sustainable economic development. And this will require digital twin infrastructure or services will require definitely geospatial and location intelligence component with interplay of map and terrain data, real-time traffic and demographic and climatic information, like say what you call cumulative effect. In subsequent slide, there are slides on cumulative effect, which deals with what you call uh, systems and processes dealing with social dimension of a city, of urban space. So those processes, those specifications with interplay of technology like sensors and other things will give a integrated interconnect digital twin system. Now, technologically, understanding of digital twins means
Yeah,
there is a
Mr.
basic
Vishnu,
model. Yeah,
Mr. Vishnu, then the
yes,
button
sir.
called hide, you hide Kardo, that it is slide. Some said
Okay, okay,
last
okay,
line is getting that it is hidden. So you hide that. So
okay,
that will go away.
okay.
Okay,
Yeah.
thank you.
So there are 5 pillars, technological pillars of digital twin. One is what you call basic model, which deals with real world system, but they lack some kind of intelligence, learning, or autonomy, limited functionality. So there are basic models which are maybe currently existing in silos related to transport system, pollution systems, and so on. Second part is sensor. Sensor is a digital model with some capacity for feedback and control. So if you have a sewage line and there is a sewage monitoring sensor and it is giving you a feedback in terms of some fault, certain things, and you are fine tuning your basic model, and you are providing some intelligence, real-time intelligence through sensors. So building temperature sensors which feed information about back to human operator. So these kind of examples. Third is you add, each block is adding to more intelligence in the system. Predictive. Now digital model, now predictive stage include basic model plus sensor with features like predictive maintenance and analytics and insights, predicting the, for example, life expectancy of rail infrastructure, enabling repairs, replacement before asset get failed. Now these are the stages of digital twins platform development. Fourth point is real-time communication. Now we are talking about the 5G. So you need information communication for digital model. You need to have a capacity to learn efficiently from various sources of the data, including the surrounding environment, the model, and ability to learn in an autonomous way, and automatically communicating a real-time, say, route recommendation, information about movement of vehicles, for example. Uh, Drivers can plan their routes and other things. Fifth and final stage, you enable that basic model with sensor plus predictive plus real-time communication, and then you add artificial intelligence at top of it, so that you give more autonomous intelligence to the system. So these are the 5 stages of development of digital twin platform. Now here I would like to say, in all these stages, location is very critical, where geospatial comes. There is also a what you call geovision. If you see the geography is a core science of geospatial, and geography by default is science of parallel processing. And whereas traditionally computing was sequential, but with arrival of what you call sensor, real-time communication, predictive modeling, you are getting data real time. So real-time data need to be cached at top of geographic file platform, and must produce artificial intelligence based analytical models to have real-time analytics. So this is what is, in a way, geography or geospatial represents science of where. Sensor real-time communication is science of when. And when you go for predictive analysis, big data analytics, artificial intelligence is science of what. So when we move from a stage of creating platform silos to geospatial platform to digital twin, these are the layers of larger ecosystem which we are trying to build as a national program. So ultimately, science of where, science of when, and science of what should get seamlessly interconnected with standards and specifications as which are being developed to create these kind of integrated, intelligent, autonomous systems. Urban digital twins, what is our understanding? In urban planning, success in any use case relies on being able to integrate data from various segments, whether it is transport, network, land use, energy, water, waste management, to enable effective analysis and avoid rebuilding basic requirements each time. So you try to connect, integrate heterogeneous systems to work together to achieve a common goal: optimum performance, optimization, robustness, and reliability. So this is what the ultimate benefit or goal of digital twins, which we are trying to address in urban space. Now let us come to spatial data infrastructure or geospatial infrastructure, which is definitely, this is with the core or what you call kernel of urban digital twins. Now, key component of SDI, there are 4 key components of SDI. One is geographic content, data and metadata. Second is technology, tools, standards. Third is policy and governance. And fourth is organization and cooperation. Now, geographic content, data and metadata, this is very key in case of physical space. For city like Meerut, for example, you need a large scale base map with say ground accuracy of maybe 5 to 20 centimeter. You need a master plan of the city with in say up to say 10,000 scale. So all those creating a base of foundation geographic data, form mapping, content requirements, that should need to be placed, taking care of all urban planning and governance requirement. Now, technology, tools and standards is standard interfaces, systems and services, interoperability, enabling technology. Now, this base data is going to be value added in terms of use cases, applications, in terms of processes of data updates from ground. That real-time data may be from IoT sensors. It could be from through mobiles based systems. It could be from drone, UAV, satellites. So this is technology, tools, standardization. All these things will be part of this component. Third is policy and governance. Now, which deals with basically access policies of data, security of policies of data, and also certain decision rule part which will operate on geographic data, like say environmental clearance, for example, is given based on certain EIA notification. EIA notification gives, say you cannot have any structure say within 5 kilometer from protected area boundary or eco-sensitive boundary. Those policy governance decision rules is another part which will lead to be related to policies, licensing, market behavior, also legislative figure, funding and pricing also. And fourth is organization and cooperation, the how stakeholders at various levels who are part of data capture system to delivery of services, including decision makers, can interact and can cooperate and have partnership through SDI infrastructure. So these are the 4 components which deals with SDI, and these 4 components perfectly dovetail with the goals and objective of urban twins. So if you see by definition, these 2 things are getting dovetailed perfectly with urban twins. And also, as I said, say science of where, science of when, and science of what. Science of where is geography, science of when is IoT sensors, UAV, drone, various data, and science of what is various analytical AI and like big data like things. Now this ecosystem will integrated ecosystem, interconnected system will be the foundation for digital twin ecosystem. These are the building blocks of SDI. SDI includes all aspects related to spatial information, including structure of the data. A structure means its design, its attribution, taxonomical classification, content standards, all those things are covered in that. Systems to disseminate web services, what kind of services and how real-time services can get embedded in workflows of e-governance systems or governance system. So data structure, application schema, data description, feature catalog, metadata, data and content and metadata capture operations, data management, discovery, access and transformation. All these will be part of spatial data infrastructure for service delivery. There are OGC web service standards. There are 5 categories of standards. This facilitates, you can have a common spatial data repository as a single source of truth, and common base information can be accessed as a service through API and integrated in various vertical applications without duplicating the copying physically data from one server to other server. So OGC Web Services facilitates cloud-based access of map as a service to various applications. In fact, in NIC, we have a map service portal where, as on date, 32 kind of map services, OGC compliant map services, we are giving to all levels of applications from national, state, and districts. Even district authorities, some of the district authorities are accessing our map service from cloud and combining that map service with their local data related to the COVID management and so many things to give necessary support system at ground level. So web service standard 1, what they call WMS, web feature service, web coverage service, web catalog service, and there are services related to what you call some sort of an interface between geospatial and digital twin requirement. OGC sensor web enablement uh, enables developers to make all type of sensors, transducers, and sensor data repositories discoverable, accessible, and usable via web. So since sensors has locational component embedded with that, so with that location, real-time information gets merged with the base map or WMS service and or web feature service, and then further get analyzed. Web map service is a mostly image-based service to visualize. Web feature service is being used even for editing of geospatial metadata on web, on providing some sort of a web editing tool or attribution tool to field people. Web coverage service is used for retrieving multidimensional coverages of information in space and time. Web catalog service is for cataloging of metadata and update of metadata so that currency and timeliness of data services can be maintained. Now, these are the broad classification of OGC web service standards. Apart from that, OGC has mechanism to set content standards, which is also very important in urban digital twin domain. Like there is a content standard on soil, the content telecom data content standard, power data content standard, inland waterways data content standards. So all those data content standards combined with web services standards, data content standards are used to structure the data in terms of spatial, non-spatial, and attribute information. Whereas these web services, one, data is structured and data is available. You can create web services, geospatial web services, using web service standards. There are emerging technologies which are being very important in context of geospatial infrastructure as well as digital twin. And like say, machine learning is an application of artificial intelligence that provides system to ability to automatically learn and improve from experience without being explicitly programmed. Now, let me tell you one thing. In terms of knowledge, AI and ML was available, and remote sensing and image processing community were using traditionally the models, the training subsets, the supervised and unsupervised classification systems in satellite imagery data interpretation. Those algorithms and models to interpret satellite data for forest cover, for water bodies, for agriculture, for vegetation index were already there since last more than 40 years. But during earlier time, power of computing, power of speed in terms of communication, power of storage were major constraints. So processing large satellite data to automatically extracting a feature, or for change detection, forest change detection real time, was not possible. Today what is happening with growth of image processing and remote sensing satellite systems, earth observation systems, where many of the companies and organization and is providing real time coverage on daily basis of entire globe up to 3-meter multispectral imagery with AI and ML models, data models at top of it for analytical purpose. So with advancement in image processing, earth observation satellite systems, AI and ML has become much more real time, an increase in computing power, increase in communication speed. So this is for digital twin technology implementation, is this is the very right time to for India to take it off. So we already have knowledge. Country has have a vast pool of people who work different in different verticals. So if we can combine them their effort, collaboration of universities, research institutes, organization like NIC, ISRO, if we combine their ISRO, Survey of India, and so many other organizations, if we combine their effort, we can come out with best applications, best platform and models. So this is what. Then I have talked earlier about CE, cumulative impact. Now current data driven and computing intensive cumulative impact analysis. Now here comes the social dimension of digital twin, and social dimension where climate data, ecosystem data modeling, resource monitoring, change detection analysis, that is a dimension which has to interoperate or interplay at top of technology tools and applications, using data models, using predictive model, using sensors, communication systems, and AI. Third part, which is written here, open API specifications, agnostic interface, RESTful APIs for both human and computers to discover and understand capabilities of services. Now, there are different verticals. Say there is a vertical which deals with the land data. There is a vertical which deals with transport data. There is a vertical which deals with solid waste information. Now these verticals has to talk to each other through open API, specification based RESTful APIs. Now this is currently with GIS, geospatial platforms, because this gives us the what you call make your application, your platform dynamic. Your dependencies on real-time database updates gets reduced, because concern vertical take care of update part, and whenever data update happens, API through API on single window system, information get updated. There are currently now IoT part. There is a IoT sensor web specifications from OGC also. W3C web of things specifications are also available, along with W3C when we talk about it's the cloud technologies. Similarly, blockchain systems, and blockchain system success definitely depends on what you call a smart contract. And a smart contract means you have to have precise, accurate geospatial information, which could be a part of any kind of maybe property related supply chain or selling and buying process. If you don't have precise and accurate ground information, the smart contract or electronic trust cannot be developed. So these are all emerging technologies, and standards are to be interconnected. There has to be interplay of all these technologies in context of digital twins. This is the slide which talks about the available Meghraj cloud infrastructure of NIC, and which we are now using very effectively for various ICT platforms and geospatial platform services. And this is the one of the uh, framework which will be part of what you call systems of systems approach for digital twins. Everybody knows about the mandate of NIC, technology partner of government, providing ICT infrastructure on demand, design, develop IT system for government, explore and advise use of emerging technologies. I am just putting these slides because for GIS, geospatial, for digital twin, heterogeneous data sources has to be integrated. So there is a open data initiative which provides data sets which are in open data, and certain numbers are written here. Those data sets, those APIs are available, which could be used and integrated through APIs on digital twin platforms. We have map service portal, OGC compliant map service portal, where map services related to foundation data, including starting from administrative boundaries to village boundaries to transportation network to various point of interest of government locations of schools, banks, telecom infrastructure, through as a service to be integrated in various workflows and systems of e-governance. This map service portal is currently available in government to government domain, and it is some sort of giving secure license, developer license to developer, so that they can call the service from cloud and integrate in their apps. So this slide is basically a representative model for heterogeneous systems of systems and has a lot of relevance in context of digital twins. So cloud, security framework, spatial framework, heterogeneous system, geospatial service integration using Bharat Maps and ICS GIS platform, and various verticals related to land use, 3D city, transport system, Department of Post, financial services, energy services, slums, grid and city planning, Swamitwa, Abadi area map, drone data, Jal board, water supply networks, and so on, so and so forth. So ultimately, in context of digital twins, you have to have some sort of kind of systems approach, so that on common digital thread and with real-time information, digital twin system can emerge at top of existing systems. This is the existing geospatial framework, which has at NIC all India base map, including large scale base map on 1/1000 scale for certain cities, more than 1 million point of interest data of government asset, providing geocoding and reverse geocoding services, provided various application services to government, navigational of the services. We have national portal, state GIS portal, and map service portal for sharing of map as a service. This is the Bharat Map as a multi-layer GIS platform, which is mobile friendly, is available bharatmaps.gov.in and stategisportal.nic.in and mapservices.gov.in is available for use in governance applications. These are certain examples which we are giving various heterogeneous ICT platform which will be having a relevance of, say, in a digital twin context. Say like transport framework, we have already certain applications like Vahan, Sarthi, Mobile Parivahan, E-Chalan, legacy applications, National Register of Vehicles, then analytics at top of it. And this also integrate GIS and what you call pollution control interface with insurance agencies, various companies, and there is a centralized application for RTOs, information on dealers, fitness centers. So complete ecosystem of all stakeholders is at one place. Now, how this information can be used in context of integrating transport data with, say, environment data, traffic planning, road planning in context of urban city, because real-time digital threads should come from this platform with locational intelligence to digital twin system. telecom network, entire BharatNet program, optical fiber route connecting to Panchayat is available through this platforms. Base platform is Bharat Maps, but complete large long distance fiber route and last mile fiber route, and then the fiber route connecting block to Panchayat as part of it. It also connect to industry people who are actually involved in construction of a fiber route through mobile, because while they go for construction of fiber, everyday real time input through mobile is received through backend checker and maker system with due validation and get overlaid at top of the base framework. So all as built drawings, survey data, integration with fault diagnostic systems, which is part of what you call command and control center of BBNL. So all these things. So telecom digital threads, their services APIs currently being used, as Professor Moni has said, as per the requirement of Department of Telecom. Can we scale up those API framework of telecom thread in context of digital thread, digital urban twin? Now that is the challenge. See, the digital thread available as API services for internal application need to be further scaled up, standardized in context of larger usage in digital twins program. Financial services, it deals with more than 5 lakh plus financial points related to banks, ATMs, bank mitras, till rural banking system, and real time updates and tools have been provided to each bank, including and their each branches to update their information, web editing, or especially on fly, editing app, mobile app to each bank branch, merger for operations like merger of banks, for shifting of banks are part of the workflow. And this financial infrastructure can be used for hot spot mapping for financial transactions related to specific applications. Now, how this financial infrastructure in connection with, say, land use infrastructure or transport infrastructure should get integrated in context of what you call digital twins, that is a challenge today. Similarly, there is an outbreak framework for service delivery. We have used uh, NIC's Bharat Map services for mapping of for COVID management services, for application of portal detailed like insight of the COVID-19 status in, say, particularly in district like Nandurbar, which is a tribal district in Maharashtra, and he has mapped information like swab tests performed, total number of positive active cases, along with the health infrastructure. Application shared with PMO, Ministry of Health, ICMR for mapping of the COVID infrastructure for management and other things. Now, this is another dimension where on same geospatial platform, you can map your health disease related information, and which can be further be remodeled in context of digital twins. Land use framework, this slide deals with E-Dharti geoportal of land and development organization, where 65,000 properties of LNDO, Ministry of Housing and Urban Affairs, has been put with uh, property card information, mutation, ground data verification processes, and all this is happening real time. And this is one of the model related to management of properties and land use. Slum rehabilitation, slums creation, slums is very important. Here we have created a base map of slums with a ground accuracy of maybe less than 5 centimeter. We have set up complete ground control network for georeferencing of slums. LIDAR survey on backpack, using equipment on backpack to survey 360-degree view of 5 feet by 5 feet slums has been integrated here, and this system is also integrated with their land records for land management. It is also integrated with say workflows of approvals of slum rehabilitation plans. Say all stakeholders like developers, architect who submit their scheme for approval of slum rehabilitation authority are part of this system. They apply on the platform and through workflow at the back end, and with interface to slum dwellers, the whole approval process and all kind of conflicts in terms of overlapping schemes, duplicate schemes are addressed through the system. Removal of all bogus and duplicate beneficiaries is one of the benefit of this system. Now these and this could be one of the model which could be part of scaling up to digital twins. Smart city framework, say one map, one greater Noida, one map, one Noida. This is ongoing projects where complete planning, large scale base map creation, ground control setup, then vehicle management systems for solid waste management, land management in terms of court cases, their layouts of land, everything is covered in this project. So this is a direct use case of a city which, and real-time information through sensors about vehicle movement is also integrated here. So this is a direct case which has use case relevant, having a relevance to urban twins. And on the same base infrastructure, COVID related information, their park related information and many other information are integrated and geotagged, and we are providing integrated solution for complete master plan and large scale plan of the city. Vehicle tracking location system, this is a part of transport network as well as a part of what you call even application like Greater Noida, where we monitor, track public vehicles through GPS based tracking devices fitted in vehicle, send a panic alert and activate an emergency response, and all and command control center to monitor it. So integrated in ecosystem, integrate VLID manufacturers, test agencies, retrofitment centers, state admission and RTOs. SOS features pressing of panic button triggers emergency response procedure to support passenger in distress. Now this can be contextualized in context of urban twins quite nicely. National Power Portal deals with power sector information on transmission, urban distribution, generation, rural distribution, capacity, fuel management, and all that kind of thing. Here now, slowly we are moving from machine to machine data transfer and advanced AI-based data modeling on the same portal. So now at least I can say 50% data is directly coming integrated with their SCADA systems of various utilities on from using machine to machine transfer. Then we are closely working on Swamitva scheme of Ministry of Panchayati Raj, where drone survey is being conducted for Abadi area in villages, and that data along with basic information on land, water, soil and various government schemes, we have created a special planning platform for Gram Panchayat. This could be valid for urban panchayats, urban local bodies also. So this is one of the comprehensive platform where data from various sources related to what you call terrain information, schemes information related to say NREGA and other things, and various the drone image information, satellite data information has been brought around panchayat boundaries for spatial planning and data modeling. And in this project we are closely working with many mentor institute, school of planning and architecture across the country to create further analytics and data modeling exercise on that. So moving ahead with geo-ICT based systems approach to support urban digital. So far, I have covered basic fundamental definition of twins, urban twins, geospatial OGC standards, various emerging technology standards which are quite important for interconnected connected autonomous systems. I also covered certain use cases or existing platform services which are verticals, and as on date they are in silos or developed as per the internal requirement of a particular domain, which could be scaled up and contextualized in context of urban twins. Now I'm moving from towards how further we should strengthen systems of system approach to support urban digital twins. Now we have there are three steps which is written here in this slide. One is virtual representation. Virtual representation is set of correlated digital models and supporting data, which includes metadata, master data, reference data, spatial data, or time series data, which provide cohesive information about their urban matters. Now, this could be a geospatial based information, real-time data coming from sensors, or maybe a satellite platform, satellite imageries. Second point is digital model. Digital model can be 3D CAD models, mathematical equations, databases, models related to, for example, a based on physics knowledge. For say, for example, water flows studies deals with lot of physics based models, AI based model, even Excel kind of spreadsheet. All these can serve as some sort of a digital representation for simulation purpose in subject matter related to urban digital twins. Then third part is classification of models, which consists of structured information and represent state of entities and processes. So one is virtual representation, what you call, as Professor Moni described, the digital thread real time coming, which operates on that digital models like 3D mathematical gets operate. Then you classify those meta models in terms of entities and processes and create a simulation model, which is executable model of a process which consists of data and algorithm, and with complete input output operational management and models like that. So ultimately what we are, this should happen in a, this entire virtual representation has to be geo enabled, it should be 3D, and it should be in perfect sync, it should be synchronized. Synchronization means component A is to cause the virtual representation to match more closely the real world. So whatever the virtual digital thread information is coming, it should represent very close to real world. And so there should be complete synchronization in real world and virtual world. All urban digital systems must have synchronization mechanism that can mirror the real world, and virtualization through observation. Say now, for example, rise of water. So all that information will come real time through sensors in a from, and when if in a river, if water is rising, this information is coming through sensor, and your model is perfectly in sync with reality. And when intervention and alert goes real time to open the floodgates. Now this kind of synchronization is required. So thirdly, this synchronization has to be both way, it cannot be unidirectional. Means you are getting feedback digital thread from ground real time, but alert and action thread should also go to real time. So it has to be multifaceted, bidirectional, synchronization, which could include sensors, laser scans, satellite imaging, radar, and so on, so forth, robotics. And the synchronization should have a characteristics of fidelity in terms of precision and accuracy for virtual representation as a synchronization mechanism of real world. So the fidelity needs to be sufficient for desired use cases. So you must get very precise, accurate information, and which should be bidirectionally synchronized for creating a virtual model and taking it forward as a operational model for process and implementation. So there are policy intervention in geospatial technology and digital twins related to land acquisition, economic development, housing programs, emergency response, crime analysis, and tax assessment, and so on and so forth. As I said earlier, these policy intervention has relevance in modeling of decision rules, in modeling of criterias for starting from virtual model to operational model. So these decision rules characteristics, what should be possible, what should be allowed, disallowed in governance system, starting from land acquisition so for say the acquisition of private land by the government has certain legal criterias. So all those could be a part of systems and can be coded as a decision table. Similarly, economic development processes can also have a decision making tools which could be part of visualization and modeling, analytical and collaborative platform. Similarly, housing renovation programs can also have geospatial analytics based on decision rules, emergency response. These are some of them. There could be many point depending upon the nature of application, which needs policy intervention on geospatial technology as well as digital twin for future use. These are the some of the players listed who are involved in geospatial technology as urban twins. So these are the companies, vendors across the globe available here. In summary, I want to say that there are two components of national digital twin programs. One is digital twin ecosystem itself, digital representation or replica of a physical asset. It could be building, road, railway, or entire city, and also associated processes and services. Supporting robust geospatial ecosystem, what you call SDI, location intelligence to digital twin to model and simulate changes in the real world. Location intelligence is today part of every software, including hardware, where which without which digital twin is not possible. Other point, digital replica represents machine readable connected system in space and time, connected with various subsystems like geospatial, BIM, IoT, big data, AI, ML, and so on. This also take cares cumulative impact of various physical systems and processes related to environment, climate change, health, disease, and transport, what you call social dimensions of digital twin. Important role of OGC in terms of standards of data interoperability and exchange among various subsystems of SDI vis-a-vis digital twin ecosystem is very important. And next is ICT based systems approach. You cannot discard the legacy systems. You have to scale up existing systems to digital twin specifications and requirement. So systems approach is a core foundation. Digital twin, this is a final statement. Digital twin needs to be based on best practices and standards to make best use of ICT based systems approach. OGC is to provide processes, functional specifications with involvement of people and organization for dynamic evolution of cities in space and time. Also, I feel there is a requirement of SWOT analysis of existing ICT and geospatial platforms available in urban space today in terms of hardware, software, and human resource infrastructure and their capacities to scale up to establish digital twin ecosystem as digital replica of physical space. Now, this study means Professor Moni is suggesting Center of Excellence for Urban Digital Twin as a collaborative project. This will be one of the key requirement. How if we have to uh, do the paradigm shift from existing ICT platform and silos to digital twins, what kind of effort in terms of hardware, software, human resource infrastructure, and its capacity will be required. At NIC, we are creating cloud-based system of systems platform embedded with OGC compliant geospatial infrastructure and services. Because recently, what has happened, because of geospatial, we started integrating attributes from various verticals through their API and KPIs on single base map. Now that process, and also a API microservice based API system or API platform at NIC, those systems, technology systems, are already started coming and they are in place. And also, so there is a paradigm shift from data storage or what to data service delivery. We are talking about today data cubes which can store large data and deliver in no time large geospatial data of satellite imagery. There are platforms like Sentinel Hub today globally available, or Planet platform, or say platform for specific domain like Global Forest Watch, which are delivering real time satellite imagery services on daily or weekly basis through what you call data cube technology. Now these are the things which are happening now. Urban digital twin needs to take benefit of what systems are available and create a what you call roadmap with appropriate SWOT analysis to scale up the existing systems with systems of systems approach. Thank you very much.
Thank you, Mr. Vishnu Chandra, for your very innovative and very meaningful address to the audience of the international webinar series on open source digital technologies for self-reliant India, Atmanirbhar Bharat, on the topic National Digital Twin Program, Need for a Robust Geospatial Infrastructure. You have really brought a thread between the National Digital Twin Program and need for a robust geospatial infrastructure. You said it that, very nicely, that a lot of things are happening, and a lot of institutions are applying technologies, invested heavily. They created vertical silos, and their real essence will be known when they get connected to deliver their information services for a common cause. That you said it, that when you would like to have a cumulative effect.
True.
Previously we used to talk about population carrying capacity. Now the population, previously it was countable for an area, but now there's all digital information which gets generated from different source of generations, data points. Or now we have to see that the similar terminology is called the cumulative effect. What will happen? Are you in a position to digest those data which gets generated from different data points?
Every individual is a data point, sir. Today every individual is a data point.
And then the thing is that you said it, that things are happening elsewhere, but is it happening here? Are we working for a common cause? Does anybody understand the cumulative effect of impact? Take it 750 districts of the country. It is a city of cumulative effects. And many of the district headquarters and tier 2 cities, tier 3 cities, nobody has got the basic study of carrying capacity. And if the carrying capacity study is not there, if the geography study is not undertaken at the grassroots level, because geography is essential for sustainable development, and geography is not as a subject is being taught as a compulsory subject up to +2. It is becoming optional. And if a development has to be taking place, economics and geography have to be taught as a compulsory subject for every student. Economics is necessary for planning, and geography is necessary for sustainable development. Economic for sustainable growth, and geography for sustainable development. You said it very nicely. Science of how, science of what, science of where,
science of where, science of when, and science of what,
and science of how, and science of why, and science of by whom, and science for who, and science by whom. And these are all some of the things that it has to be imbibed in our educational system. You said it very nicely. I was completely glued to your talk. I'd also taking notes that it is very important. All the organizations in government, whether a digital organization or non-digital organization, they are using digital technology, digital assets, and digital systems. They are developing it, but have they bothered about the cumulative effect?
True.
Have they bothered about that what the man sitting on the last mile is able to understand? Whether the information is reaching him in the way in which he wants to have it, or he is desiring it. And this is a very important thing, that now technology is playing, infrastructures are being created, and how the information will reach the concerned and respective people, it's more important. And in that connection, the topic is very much it's relevant, and it's a concern for the government, both the central government and state government, and concern for district administration, concern for local bodies, concern both the local, the panchayat level and urban bodies, municipalities, tier 1, tier 2, tier 3 cities where economic development has to take place, MSMEs, 63 million, MSMEs, and they need to have Industry 4.0. They have to be digitalized, and they have to have this digital twin program for their productivity, for their shop floor, for their what they produce has to have. They have to adopt it if they would like to, be a global enabler, global enterprise. So that's why from this webinar series, we purposefully put it as a self-reliant India, that every primary industry, primary sector, secondary sector, tertiary sector, quaternary sector, even the fifth order sector, whichever is involved, how this digital, twin program can, facilitate them. Because, they are all working on very little margin of profit. And the digital technology has to facilitate them. Digital understanding has to facilitate them. This is where we have to have a strong digital infrastructure and strong information infrastructure, whether it is a spatial or non-spatial. That's where the informatics and e-governance programs have to be revisited. It is no longer the topic in terms of computer science and data structure being taught in various higher education institutions. It is a collaborative study of understanding, and people have to understand technology gets evolved. Are we part of the technology development, or we are the part of the technology usage? And this is very important, and I'm very happy that both myself as the moderator and you as the speaker, give a lot of, justification for the topic of today's webinar, National Digital Twin Program Need for a Robust Geospatial Infrastructure. I am very happy that if it is possible, the time has come that many of the, I quoted purposefully the National Digital Twin Program of Britain, which has emanated from the University of Cambridge. It is the Center for Digital Built Britain. It's a center which is functioning from the University of Cambridge, which they are building the National Digital Twin Program by involving all the stakeholders. And in India, we have got almost all institutions and bodies and so on and so forth. The problem is that, that they really, whether their mind is getting integrated, whether their mind talks to each other. It is an M2M communication. This is where Industry 4.0 technology has to be enabled, not only in goods and services sector, but also in government sector. It's more than e-governance. This has to talk, and you brought out very nicely almost all frameworks. I was also part of the system in my entire career. I understand. We started with the district information system way back in 1985. I was the project director. We visualized it. It's 28 total database development program we visualized. And that time we put a component of National Natural Resource Management System component. GIS as one of the basic component of district information system program. But 1985 and today 2021. And we have large scale remote sensing data with a higher resolution. And is there any, I have recommended, I have talked when I was having in the meetings in ISRO, that why can't we create centers of spatial information systems in various department of geographies, where geography is being taught in about 120 colleges. And unless we bring understanding of this technology from bottom up, from the school level, from the higher education in the educational institutions and the special institutions, research bodies, and taking advantage of such technology, which is evolving like anything, because digital technology is like a twin blade. It's cutting across everywhere, and COVID situation has taught a great lessons to us. And it is digital technology has to be the digital thread for us to work. And I'm very happy that today we have done some justification for the topic, for the technology understanding, and what we should do, how we should move, and how to approach. And you said it that that virtual representation, digital models, and the models classifications for further research. And I'm very happy that if possible, I'll be very happy to have an institutional collaboration with the National Informatics Center, my alma mater, and my the university where I am associated as a Professor Emeritus and Chairman of 4 Centers of Excellence. This is the only private university which has established 4 Centers of Excellence of emerging technology for 2 sectors, agriculture and industries, through 4 Centers of Excellence: Center for Informatics Development Solutions and Application, Center for Industry 4.0 Technology Studies and Application, Center for Agricultural Informatics and E-Governance Research Studies, and Center for Agribusiness and Disaster Management Studies, to promote technology-based development in rural areas, to make rural youths understand and acquire this emerging technology. And with that, I would like to thank and also give warm greetings to all the participants who are joined for today's international webinar series on open source digital technology for self-reliant India, Atmanirbhar Bharat. Mr. Vishnu Chandra, thank you very much
Thank you,
for
sir. Thank you.
joining in today's webinar series, and you have done a full justification. I am happy
Thank you.
as your former
Thank you.
mentor. And I still
Thank you.
remember.
Not perfect. You are still my mentor. Thank you.
And I'm very happy that when 1990, when you are asked to come from Lucknow to Delhi to join National Natural Resource Informatics Information System Project, NRIS, I know the development, and I know that the journey which both of us walked together, and we put the seed log by more than 3 decades ago, and that time technology was not available, and getting technology was the biggest problem. There were a lot of agencies want to stop our activities. They wanted to give free software so that we can stop our thinking process. Institutions were not working together, and even now, with the digital technologies, digital applications, digital systems, but many of the systems are not talking to each other. It is many applications are duplicate in nature, not interoperable, and something has to be done because taxpayers' money is being invested like anything for the system which they are not talking to each other. And so this is where, as a former Director General in NIC, I am very much concerned. And that's why I even launched an MTech program on informatics e-governance with the standards-based approach. E-governance is not merely building portals with some technology. Even portal design specification is not appropriate, which has been, which is available. If you can go through the, many of the tender documents with the portal specifications, they're all, you show the face and I will create a, tender document. That's the situation which is going on. So we have to overcome the problems, and, digital twin program, National Digital Twin Program is needed up to the panchayat level, and let it run over BharatNet infrastructure, but we need to have a robust geospatial infrastructure. It means that we have to create a lot of human resources development in the area of capacity building for sustainable development on geospatial technology. So this is an important thing, and we from the university we are launching an MTech level program on geospatial technology, having these aspects as the core. And for that aspect, I would like to have a strong support from my alma mater, National Informatics Center, for undertaking this in the from the city of Meerut, from the University Sobit Institute of Engineering and Technology, deemed to be university. Thank you very much. With this, we close the webinar and leave studio. Thank you very much.
Thank you. Thank you very much. Thank you, sir.
Thanks for your participation, and greeting from Sobit University. For more research inquiries, please contact Professor Moni Madaswamy, Professor Emeritus and Chairman, Center for Informatics Development Solutions and Application, and Center for Industry 4.0 Technology Studies and Application, and former Director General, National Informatics Center, Government of India, New Delhi. My email ID is moni@sobituniversity.az.in. We thank the Honorable Chancellor of the Sobit Institute of Engineering Technology and Sobit University, Gango, and His Excellency Secretary General, African Asian Rural Development Organization, New Delhi. With this, we close the webinar and leave studio. Thank you. Good day.